Adding fractions. Okay, today we're going to begin looking at how to add fractions, and it's going to be the same thing for subtracting fractions, but we'll do that on another day. So we're going to focus on adding fractions. So number one thing that we need to look at when adding fractions is taking a look at the denominator. What is the denominator? The denominator is this number here at the bottom of the fraction. That's called the denominator. The top is called the numerator. In order to add fractions, your denominator has to be the same. So right now we have 3/10 plus 3/10, which means we're ready to get started on adding those fractions because we already have the same denominator. Okay, so let's take that to the next step. So our next step then, we're gonna grab that denominator and just put it down right here. So we don't actually add the denominators. We just use the denominator, and that's the one that we're going to use when we add our fraction. But the top, we can add. So now that we have the same denominator, we put our denominator here at the bottom, and now we bring the numerators to the top of this fraction. So it's 3 plus 3, because we've got a 3 here and a 3 there. And now we add. So 3 plus 3 is 6. And again, the denominator remains the same. So our answer is 6/10. And that's how you add a fraction. Now, we may be asked to simplify it further. And what that means is that sometimes we look at the result like this one, 6/10, and we notice, wait a minute, I can reduce that further. And I can reduce that further because both 6 and 10 can be divided by 2. So when we divide 6 by 2, we get a 3. And when we divide 10 by 2, we get a 5. So if we need to reduce our 6/10 further, we reduce it to a 3 over 5, which essentially is the exact same thing. So 6/10 is the same thing as 3/5. It's just that we've reduced our 6/10 even further. If you multiply both of these by 2 again, you'll end up once again with 6 over 10. The answer means the same thing. They're both the same thing. They're both correct. But if you're being asked to reduce it further, we would bring it down one more if there is a possibility to reduce further. Sometimes we can't. In this case, we could because 2 fits into both the 6 and the 10. Okay, let's look at another example. So in this case, we have 2/10 plus 1/5. Okay, so before we start anything, what did we say? We want to make sure that our denominators are the same. So are they the same right now? We've got a 10 and a 5. So they're not the same. So we need to make them the same so that we can actually get started. Okay, so I'm just going to rewrite the question right now so that we can start working on it. So we've got here 2 over 10, okay, plus 1/5, so 1 over 5. All right. Okay, so when we look at these, we see that we have two different denominators, and we need to make them the same in order for us to add the fraction. So I usually like to look at the lowest one. So when you look at both numbers, take a look at your lowest number and ask yourself, is there anything that I can multiply by the 5 to that will give me 10? So can I multiply 5 times something that will give me 10? That is the easiest way to start. It's not always gonna work, and we're gonna go through another example where we need to do a little bit more thinking, but always start here because the majority of fractions, you'll notice that you can actually do that. So is there anything I can multiply the 5 to that will give me a 10? Well, guess what? There is. We can multiply 5 times 2 because 5 times 2 equals 10. So that means we're going to use that to be able to get the same denominator. Okay, and so we're going to take this another step here. So there's nothing that we need to do to this fraction because it already has the 10. And what we're trying to do is to have a 10 as the denominator in both this fraction and this fraction so that we can have the same denominator. But since this one already has it, we don't actually have to do anything to that fraction. So we're just going to rewrite it the way that it is. So we've got 2, okay, and we go plus once again. But this time we're going to change our numbers here. We said that if we multiplied it by 2, we can actually get the same denominator. Now you'll notice that I'm also multiplying the top, the numerator. Well, that's because whatever you do to the bottom in the fraction, you always have to do it to the top. So if I'm going to multiply by 2, I also got to multiply by 2 at the top as well. So in this case, we go, okay, 1 times 2 is 2. And 5 times 2 is 10. Now we notice that we have the same denominator. So we said if we have the same denominator, then we can actually do our adding. Okay, perfect. So let's go to our next step. And we're going to have 10 at the bottom because we said that's going to be our denominator. And we can now add the top of our fraction so that we can add them. 2 plus 2. And that then gives us, if we add 2 plus 2, we get a 4. And I said oh, this doesn't look so nice, like a 4 right there. And the denominator is still 10. So our answer, okay, of 2 tenths plus 1/5 equals 4 tenths. Let me redo this for, I don't like how it looks. It looks a little bit confusing. I don't want you to get confused there. Okay, so this is a 4 right there. Okay, so now if you were asked, okay, well, can it be reduced further? Can you look at this number that we got and can we make it even smaller? Is there a number that can be divided into both of those? Okay, so is there a timetable that when we look at it, that timetable can give us a 4 and that timetable can give us a 10? Okay, the answer is yes. We've got the 2 times table. 2 times 2 equals 4, and 2 times 5 equals 10. So we can actually reduce 4 tenths down to 2/5. Again, means the exact same thing, but if you're being asked to reduce it further, okay, then we want to show this one right here. We want to always look at our fraction and say, okay, can we make it smaller? Can it be reduced further? And in this case, it can. Okay, here we have another example. So we now have 3/4 plus 1/3. So our rule number 1 is checking the denominators. So when we look at the denominators, do they have the same denominator? No, they don't. Okay, so then we go into our next step, which is trying to make the same denominator. We need to look at both of these fractions and actually get to the same denominator so we can start adding. And so how do we do that? We need to find a number that they both fit into. Now, I had said before that we could always look at the smallest number and ask ourselves, okay, is there something in this table? So for example, the 3 times table, because this is the smallest number. Is there something in the 3 times table that if I multiply 3 by something is going to give me 4? Well, in this case, no, there isn't, because 3 times 1 is 3 and 3 times 2 is 6, which is higher than the 4. So no, it won't work. So when that happens, we actually need to find a number that both of them fit into. And so this is why I said it's important to know your timetables, because if you know your timetables, you know this right off the bat. If you don't know it, you actually have to look through your timetable sheet or your timetable, I guess, yeah, it's called a sheet or a table. What's it called? The facts, or your time for your facts. And you need to see, okay, what timetable, okay, what number that when you multiply it by 4, so when you look at the 4 timetable and when you look at the 3 times table, there's got to be a number that you multiply into that will give us the same thing as something times 3 will give us. In other words, when we're going like 4 times 2 equals 8, okay, in the 3 timetable, is there something that also give us 8? So 4 times 2, let me put it here, 8. Okay, now we got to look at the 3 times table. Is there something in the 3 times table that gives us 8? Well, 3 times 2 is 6. So no, it's 6. And then what about 3 times 3? Well, 3 times 3 is 9. Okay. All right, well, let's go with the 4 times table again. What about 4 times 3? And we'll look at the 4 times table. We know that 4 times 3 equals 12. Oh, wait a minute. Is there something in the 3 time table right here that also gives us 12? Oh, wait a minute. Yes. 3 times 4 equals 12. So 3 times 4 equals 12. Okay, so we finally found a number that can actually be used as the same denominator, because there's something in both timetables that will give us the same result. 4 times 3 equals 12 and 3 times 4 equals 12, which means we can use 12 as our denominator. In order to do that, we got to actually multiply each of these by the number that's going to give us that 12. So let's grab a different color so we can look at what we're doing here. So the 4, we said we're going to multiply by 3. And we said whatever we do to the bottom, we also got to do it to the top. So since we're multiplying that number by 3, we got to multiply this number by 3. When we look at the 3 now, what do we need? We need to multiply this 3 by to get the 12. Well, we got to multiply by 4. So that means we're going to say, okay, so 3 times 4, we're going to multiply that one here. And whatever we do to the bottom, we also do to the top. So 1 times 4. Okay, we're ready for our next step. So in our next step, we're going to get those multiplications going, which is going to give us the denominator that we're looking for. And we're still not going to, we're going to keep them separate still. We're not going to put them all in one so that we can do everything step by step. So step number 1, let's multiply the top. 3 times 3 is 9. Okay. And 4 times 3 is 12. Okay. 4 times 1 is 4. And 3 times 4 is 12. So we got what we wanted. We have the same denominator now, which means we are ready to add. So now we make our big line, put our 12 in the bottom, and now we can add the top. 9 plus 4. Oops. And that will give us 9 plus 4 is 13. And I said the bottom stays the same. So 3 over 4 plus 1 over 3 equals 3/12. Okay, we got another question here that we can work on, and it's 7/10 plus 3/4. Okay, so once again, what do we look at first? We look at the denominators. And so are they the same? No, they're not the same. So can we add already? No, we can't add because they both need to have the same denominator before we start doing any adding. So why don't we do that? We need to then find a denominator that we can use so that we can start adding. All right, so I had said let's look at the smallest number and let's ask ourselves a question. Is there anything in the 4 timetable that if we multiply it by a number, it will give us a 10? Well, in this case, there isn't, because 4 times 2 is 8, which is close to 10, but it's not 10. And the next number would be 4 times 3, but 4 times 3 is 12, which is higher than 10. So that's not going to work. So we need to find something that we can multiply 4 by that will give us a result that we can also get from the 10 timetable. So let's start with the 10 timetable because that's a little bit easier for us to do. So if we say, okay, we know that 10 times 1 is 10. So we already know that that's not going to work. So what about 10 times 2? Well, 10 times 2 is 20. Okay, wait a minute. So 20 may be a good number. 10 times 2 is 20. But what about the 4? Is there something in the 4 times table that also gives us 20? Well, there is. 4 times 5 equals 20. So we have found our denominator that we can actually use. It's called a common denominator. Okay, so 4 times 5 is also 20. So that means that 20 is going to be the number that we're going to use as our denominator. In order to do that, I said, well, we're going to have to then multiply these numbers the way that we have done so that we can then get that 20. All right, so let me pick a different color here so that we can work and see what we're doing. Okay, so what are we multiplying the 10 by in order to get that 20? Well, we're multiplying it by 2. So we're going to put our 2 right here. And I said whatever we do to the bottom, we do to the top. So we're going to put our 2 right here. What about this fraction? What are we multiplying the 4 by in order to get 20? We're multiplying it by 5. Okay, so we're going to multiply it by 5. And whatever we do to the bottom, we do to the top. Okay, now we are ready to rewrite our question or our equation so that we can continue with our adding. Okay, so 7 times 2 is 14. And 10 times 2 is 20. Okay, and we keep our little add sign. Okay, 3 times 5 is 15. And 4 times 5 is 20. Okay, so now we got our common denominator. So since we have the same denominator, then we are ready to add. So our next step would be, we draw our little line here. Let's move the 20. Let's put it at the bottom here. We don't need to write it twice anymore. Okay, and we're ready to add the top. So we bring this 14. Okay. And we're going to add it by the 15 or to the 15 right here. And that gives us 29. Let me put it over here. 29. And the denominator stays the same, which is 20. So our answer when adding 3 tenths plus 3/4 is 29 over 20. Okay, for our last example, I wanted to try something a little bit more difficult, and is adding 3 fractions together. So is there a difference between adding 2 fractions, 3 fractions, or 4 fractions together? No, there is no difference in how many fractions we're adding together. The rules are still the same. So the rule number 1 that we need to remember is the denominator. We can't add anything unless the denominator is the same. So is the denominator the same in this question, which is 1/2 plus 3/4 plus 2/8? No, the denominators are all different. This one has a 2, this one has a 4, this one has an 8. So in order for us to actually add these, we first need to get the same denominator on all of them. Okay, so let's look first at our lowest number, which is the easiest way to start. Okay, does the 2 go into the 4? So is there anything that I can multiply the 2 by to give us a 4? Well, yes, I can multiply 2 by 2 and it'll give me 4. Okay, what about the 8? Is there anything that I can multiply the 2 into that will give me 8? Well, yes. 2 times 4 equals 8. Okay, that's good. So now we know that 8 is a potential denominator that we could use. But we got to check with this one because we need the same denominator in all of them. What about the 4? Is there anything that I can multiply 4 by that will give us an 8? Because we know that 4 times something cannot give us a 2. The 2 is less amount, so 2 is not a good number. 4 is not a good number because 8 is bigger than 4. So let's try the 8 that we already have here. Well, yes, 4 times 2 equals 8. That means that we can actually use 8 as our common denominator, okay? So let's do our next step, which is, okay, we said that we need to multiply the 2 times 4 because 2 times 4 gives us 8. And since we're doing that here, we got to do the same thing to the top. Okay. And the 3, we said that the 4 we can multiply by 2 because 4 times 2 equals 8. And whatever we do to the bottom, we need to do to the top. So we've got that here. Okay. What about the 8? Well, the 8 we don't have to do anything because the 8 is already 8. So we can continue with our equation. Okay. So let's rewrite it now once we multiply those numbers. 1 times 4 equals 4. 2 times 4 equals 8. Okay. And we do our plus sign. Okay. 3 times 2 equals 6. And 4 times 2 equals 8. Okay, plus. And this one stays the same because we didn't have to do anything to the bottom, so we don't need to change anything. And so now we have the same denominator across all fractions, which means that we are ready to actually add. So nothing changes, everything stays the same from what we've learned so far. We add our big line and we put our denominator at the bottom, which is an 8. And now we're just simply going to put all of our numerators up at the top here. So we've got a 4, we got a 6, and we got a 2. And we go ahead and we add them. So 6 plus 4 is 10, plus 2, that is 12. And the denominator stays the same, which is an 8. So 1/2 plus 3/4 plus 2/8 equals 12/8. If they were to ask us to reduce that further, if we need to simplify it even further, we can reduce it because when we look at both the 12 and the 8, we notice that both numbers we can divide by 2. So we can make this number smaller by dividing both by 2. We say 2 can go into 12 6 times, and 2 can go into 8 4 times. Actually, you know what? We can move it even further. So we've got 6/4, which actually can go even further down because we can still divide those 2 by 2, which is 2 goes into 6 3 times, and 2 goes into 4 2 times. Okay, so if we were asked what to add 1/2 plus 3/4 plus 2/8, we've got our answer right here. The answer is 12/8. But if we need to reduce it to the furthest down, then we would be using 3/2. That's the furthest down that it can go. It can't go any further, which is essentially the exact same thing. Just one we're reducing all the way down, the other one we're showing with bigger numbers, but it's the same fraction and means the same thing.